Hey, everybody. All right. So, on the topic of rethinking things a little bit, I want to talk a little bit about how I see code and how I look at code and try to maybe change the way that all of you think about code a little bit. So, I've called this talk Tug of War. It's about pushing and pulling in JavaScript. Again, my name is Ben Lesh. I'm the RxJS lead. One of the things that makes me qualified to talk about these things, I'm actually not going to try to sell you on RxJS or observables today. I'm going to talk about a lot of different types, including observables, but I'm also going to talk about signals, all sorts of async iterables, those sorts of things. I am involved in the WhatWG and the TC39 as an invited expert, not as a member, but I am involved in discussions for standardizing things like observables and signals. So I will get to that in a little bit. So what I want everyone to walk away from here with is that almost every line of code pushes or pulls. And it's a weird thing to think about. Everything that you're doing is pushing or pulling a value from somewhere. And just as an example of this, here's a bunch of code. You don't have to read it. It's small on purpose. This is just some code. It's some random JavaScript. It's getting some inputs when they change, or it's calculating a sum, updating an output. Not a big deal. I don't want you to read this or get into it. But when I look at this, what I actually see is a bunch of push and pull. So everywhere that's red, it's pulling a value. Everywhere it's green, it's pushing a value. Don't think terribly hard about this. I'll explain what I mean in a minute. But it's littered all over your code. Even if it's not JavaScript, if you're using a different language, it's the same sort of concept. So the other thing that you need to know about this is if you're talking about pushing and pulling, there's going to be actors in this. There's going to be a consumer and a producer when it comes to code. Somebody has to be pulled from and somebody has to be doing the pushing, right? Those are the actors. So there's consumers and producers, and I'm going to explain what those mean. Those are, again, the actors. And don't get excited, CS nerds. I'm not talking about the actor model. I mean actual actors in this act. All right, so here. So the consumer is the code receiving the value. And here we've got a very simple bit of code. We've got a function, it's returning a value, and we're logging it. So the consumer is this bit right here. That's the consumer. It's the thing receiving the value. It's also the thing that's calling the function, technically, right? It requested the function by calling getValue, and then the producer is the bit that's providing the value to the consumer. So the act of calling this, something inside of that function produces the value and returns it synchronously, right? All right, here, the consumer in this code is actually, my goodness, here we go. It's actually the body of the for loop and where we're getting the value out of this iterable, right? That's what's consuming the code. It's using the value it's consuming the value, rather. It's what's using the value. So in the producer is the iterable and the for loop itself. So the iterable on its own is not producing values. It's producing values because it's being iterated on by that for loop. And this is another example here. This is actually, those previous two were kind of pull examples, and again, I'll get to that. But this here, our consumer is this bit of code, our handler. It's getting the value pushed at it by this add event listener, right? And that means that our producer is our body element mouse move events, right? Technically, maybe if you're moving your mouse, you're kind of part of the producer in that scenario. But the code that's producing it is underlying here. So it's producer and consumer. Very important concepts to know when you're talking about push and pull. All right, so those are consumers and producers and push versus pull. Now, I'm going to need a volunteer from the audience, anyone at all. And if you guys are slow, there you go. Right there. Come on up. Josh he's not a plant. I tried to get Jay. Jay's like my best friend. And I tried to get him. He's like, I'm not going to be your plant. Okay, so here we go. Just for sanitary purposes, because I'm going to hand sanitize here, because I'm going to be handling food. Are you okay with chocolate? Are you allergic or anything? Okay, so I've got some M&Ms here. And first thing we're going to do is we're going to talk about pull. So pull is when the consumer, you're going to be the consumer, I'm going to be the producer, okay? The consumer, when they want to consume something, has to take it from the producer, right? I'm going to get a few out here, and consume it, and then when they want another one, they consume. So I've got 5 M&Ms here, And as you will, sir, take one at a time and consume them. There we go. He's consuming quite well. Don't be greedy. Oh, that's fine. You're doing great. You're not going to get sick from eating these, are you? That's good. We're on stage. All right. So he's done well. Now we've got a problem, right? Like, if you wanted to take another, what's your problem? I haven't produced any more M&Ms. There's a finite number I could produce. He synchronously kind of took them from me, and now they're gone. So the problem so pull was great, because pull, you got one whenever you wanted, right? Consumed it, and when you were ready, you took the next one. Pull's very good for that, but when I, the producer, ran out, I didn't have an opportunity to make another one, because that requires me to go back to the bag and take one out and give it to him, right? So that's the problem with pull. Now, pull is always synchronous. He gets one exactly when he asks for it. Now let's talk about push. Now, push is a little different. Push, he says, hey, I want some M&Ms, right? And I have the opportunity to get an M&M out of the bag to produce it and give it to him whenever I'm ready. Now, and then he has to tell me when he wants me to stop giving him M&Ms. Like, this is the contract. So here we go. Tell me when you want M&Ms. You gotta say it.
I want M&Ms.
Okay, there's one. There's one. You gotta eat them as fast as you go. Come on. There we go. So, tell me when to stop. You good? You drop one. You drop one. The other one's going. You better open up. You stop? Okay, he told me to stop. All right, so push, on the other hand, gave me an asynchronous chance, this chance to produce an M&M whenever I wanted. But you see the problem there, right? He's still chewing some, right? Like, he's not done. Like, this is actually a back pressure problem is what we have. So this is where the good thing is I never run out, because I've got plenty of opportunity to produce more values. But the downside is he can get overwhelmed, right? So there's an advantage and a disadvantage to both push and pull. So push, thank you, you may be seated. Very good. I've never had a volunteer in a talk before, so you did fantastic. So push can be synchronous or asynchronous, right? It could be either. If I had a bunch of values ready, I could just, throw them right there. Or I might have to produce them. I might have to go all the way to the M&M factory and make more, right? But I have a chance to do that. So we've got pull types, which I've already kind of talked about. And we've explained what pull types are good for. If you want a synchronous value, you want to get a value right now, very easy to deal with. Functions are pull types. They return exactly one value as soon as you call them, synchronously. Iterables, again, are pull types. That's any iterable is something you can use in like a for of loop, right? So you can arrays and sets and these things. Push types, on the other hand, are a little different, but you'll notice that there's something common about all of these if you look at them. So a callback is kind of the original push type, right? You provide a function to your producer, and that producer calls the function with the value when it's ready. Promises are push types. This is a little mungy, right? I'm gonna trash on promises a little bit here and say that yes, it's technically a push type, but I'll get to why it's not exactly the best push type to talk about here. And then observables, which is something I work on at ArcsJS and something they're talking about standardizing for the web, is a push type. So with an observable, you subscribe, and it pushes n values to you until you unsubscribe, which was kind of what we were seeing with our M&Ms. So generally, in JavaScript, a push can be identified by a callback function. I've got an asterisk there because it's not always the case. But if you look back here, yeah, there's a callback in every single one of those. Makes it stand out. So, except when it can't be identified by that. And it can't be identified by that when you've gotten await. There's no callback here, but rest assured, you are getting a promise there and you're waiting for that promise to push. Now, this actually illustrates one of the things about promises that makes them not exactly just a push type, which is, this is kind of both. It pulls a promise out of get value. That's a function. It returns, you pull a promise out, and then the promise pushes the value at you, right? So one of the reasons I don't really include promises as a pure push type is because they're eager, and without a function to go with it, they're relatively useless. You almost always have to have a function with it. So what about stuff like this? This is weird. This has a callback, right? But it's an iterable. I just told you that iterables are all pull types. Honestly, this is a bit of both, right? So this is, the for each is indeed pushing values at you. And one of the fun things about for each with an iterable is like if you're iterating with a for of, you can break the loop and stop iteration, right? You get a for each, too bad. It's going to call that for every single value that you've got in your iterable. So, I mean, you could, I don't know, throw something or whatever, but in this case, usually when you're talking about it in the scholastic sense, the underlying type matters more. Like underneath this, yeah, what you're consuming this as is with push, but everything that's happening underneath the hood is pull. So if you've got, an iterable they're using the new iterator helpers or something, you're saying filter, map, whatever, all of those things are pulling through. All right, promises again, they're rarely alone. You almost always have a function that they go with, so that's why they're a little different. So you've got the pull and then the push. And then observables are push only. This is you subscribe and it only pushes values at you. Very simple contract. So you subscribe, you can unsubscribe later to have it stop sending values. This is your basic observable shape. This exists in far more places than just RxJS. You could name the function something different. It doesn't have to be subscribe. It could be observe or watch or whatever. All right? So iterables, pull only. This is how you would consume an iterable, right? And you can stop it by adding a break in there or something like that. And just to illustrate this, if you desugared a for of loop, what it's really doing is it's saying, while true, like keep calling next and you look at whether or not it's done. If it's done, then break the loop. If it's not, then you use the value and you continue on in that way. You're just constantly pulling by calling next and getting the return value of that. All right, so when it comes to push and pull, iterable and observable are indeed more complete contracts. The consumer tells the producer when to start by either starting to iterate or subscribing. The producer can tell the consumer when it's done providing values, either by breaking the loop and not iterating anymore or unsubscribing. The producer can report errors to the consumer. So you can throw the error when you next from an iterator. There's an error handler that you can give an observable to make sure that it can handle an error. And then the consumer can tell the producer when it no longer wants values. So that's your unsubscribe or you're breaking the loop. I'm sorry. So the producer can tell the second one in there, I said the same thing twice. The producer can tell the consumer when it's done providing values. That is when it says, I'm done or I'm complete for your iterator or observable. All right. And the reason that these things are basically the same is now I'm going to talk about a thing called duality. And what duality is a really fancy way to kind of talk about inversion of control. If you take an iterable and you invert everything, you turn it inside out, you get an observable. And I'm going to prove it by stepping through that right now. This is essentially a JavaScript iterable. We've got this weird symbol iterator method here that's kind of put there so you don't kind of pull it off yourself because it's weird. Usually you'd use a for of loop for that. And then that returns an iterator, which is an object which has this next method on it that communicates whether or not it's done and the value. This is very avant-garde for an iterator. Most languages have two methods. They have a has next and a next. So I'm going to clean that up a little bit and not use a symbol so it looks a little bit more readable. And then I'm also going to change my next on my iterator from having returning an object with done value to being more like a classic iterator you'd find in other languages. There's a has next, so you would call, hey, do you have a next value? Yes, you do. Okay, I'm going to iterate the next one by calling next. So this is a more classic iterator pattern. And now that I have this, I've got my classic iterable iterator, I'm going to start inverting things. So I'm going to change my iterator to an observer by, instead of returning a Boolean and returning a value, I'm going to pass them into the methods. Right? I'm just going to step through this. This looks weird, I understand. But all I did was just invert control there. Just instead of returning, I passed them in. And then the next thing I do is I'm like, well, look, why would I call has next? Think about this. If I'm saying, hey, yeah, I've got a next value, here it is. Yeah, I've got a next value, here it is. Yeah, I've got a next value, here it is. And eventually I say, no, I don't have a next value. The only one of those signals that matters from has next is no, I don't have another value. I'm complete, I'm done. Right? So you don't need to pass a Boolean in there. You can just change that to be a complete. Right? The consumer only really cares that you're done. So now we've got this contract, this next and complete. The other thing that iterators can do, and it's not obvious, but when you call next, it can throw. That's how it communicates that there's a producer had an error trying to get you a value. So we need a way to communicate that through our observer. And so what we do is we just add an error method on our observer. Now we've got the complete observer for an observable. After that, all we really need to do is just invert our iterable. So instead of an iterator method that returns an iterator, we could have an observer method that takes the observer. But observer is a weird name for a method, so let's just call it subscribe. Now we've got an iterable, or an observable. Still not totally complete, because an iterable, you can stop iterating it to tell it when to stop giving you value, so you need a way to do that. And what we do in RxJS is we return an object with an unsubscribe on it, a subscription method. This can come in a lot of different shapes. You could have a cancellation token passed into your subscribe. You could have a subscribe and an unsubscribe on there, or an add observer and a remove observer on there. It's still an observable. Those are just different shapes of the same thing, but you need a way to tell the producer to stop sending you values. So, hopefully you can see the duality. Here's a simplified version of it. Those look very much the same, right? An iterable that returns an iterator that has these things on it, an observable that has a subscribe method that you pass an object to that has the same kind of shape to it, right? So, very, very similar. And it's worth noting that all of our push and pull types have duals. So if you have a function that gives you a value, that's your pull type. The push type is simply a function that takes a callback. You would invert that same thing. Also, you have to have a way to get an error out. So in Node, you would have this thing where like maybe the first argument's an error. Or totally acceptable, you could have a second callback for your error if you wanted. Just depends on how you want the API to work. All right, promises don't really fit with the whole dual thing. And this is like a sort of refined TypeScript signature of what a promise is. This only has the then method on it. It doesn't quite fit. It looks kind of similar to what I just showed you here on the bottom, like on the right-hand side. But you'll notice it returns a promise. It does some flattening of promise things. Like it's different. It's more advanced type. It doesn't necessarily have a dual. Promise is also eager, which is one of the reasons why it's useless without a function to return it. So far we've talked about push and pull. Very simple types. Pull, you've got function and iterable. Push, you've got callback and observable, and promise, kind of, okay. We'll throw that in there. But we've already touched on something, which is you can combine these for more effective things. And we've already touched on that with pull versus push. How many people here have written a function that returns a promise? Wow, and everyone that didn't raise their hand doesn't like raising their hand. All right, so this is pull versus push, or pull then push. There's another pull then push type that's in the language, and that's called async iterable. How many folks here are familiar with what an async iterable is? A few of you, all right. This is in the language, it's pretty cool stuff. All right, so what an async iterable is an iterator of promise, right? So, or an iterable of promise. And look, we're combining a pull type with a push type. So the contract actually looks like this. Again, we've got one of these weird symbol things, and it returns an async iterator. The async iterator, it returned here by this iterator method, if I kind of desugared it a little bit. It's just an object with a next method on it that gives you you pull out a promise, and that promise pushes to you whether or not it's done and a value. So the same sort of contract that you saw in an iterator, but with a promise, so it can be delayed. And these are available right now. You can play with these right now. You can use async function star. And if you have an async function star, you can await things inside of there or whatever. And everywhere you yield, it will yield out one of these awaitable values. And when you want to consume this, you can consume it with for await. You have this for await loop here, and it takes any async iterable, and it will, when it gets to the top of the loop, it waits for the next value to come. It pulls out that next promise, waits for it to resolve, and then you go into the body of that for loop, and then it gets all the way back to the top, and then it pulls out the next promise and waits for that to resolve. So the nice thing about this is if you have slow work inside of here, it's okay. Because if I've got some huge for loop in here, I don't have to worry about it generating another value or going and requesting another value until it gets back to the top of the loop. So we're kind of controlling that back pressure problem where I was throwing M&Ms at Josh, right? So this type is particularly good for managing back pressure. And pull then push in general is good for back pressure. Even your functions that return promises are very good for this. If you're like, oh, now I can handle this, I'll call the function, get the promise, so on and so forth. It's good for kind of managing that setup. Now, what is back pressure? I'm not going to dive into that because I have a lot to talk about today. But this guy in the front row did a really good talk about back pressure. He's my best friend, so I'm going to keep pointing at him. He did a fantastic talk about back pressure. I'll make sure the slides get out. The video is linked in here. There's an article linked. Basically, it's when you're getting values faster than you can process them because they're being pushed at you in some crazy way. And there's lots of ways to mitigate it, but async iterable is a good way. Like a pull then push type is very good for mitigating back pressure. So, pull then push. You only request the data when you know you can handle it. That's the goal anyways. I mean, you could still screw that up, I guess. We all write bad code. I know I do. All right, so we've talked about pull, push, and then pull, then push. Well, what if we have push, then pull? That exists. Signals. So signals are something that a lot of us use and don't even really realize that a lot of us use it. And we've been using them for a long time. What are signals? Well, I'm going to start back in the day with things that are more esoteric, and I'll get more like recent. But basically, they're also known as Ember computed props. That's one. Knockout observables. It's an unfortunate name that they named them observables. They're really knockout signals. Never mind the observable bit. That's not actually an observable. Sorry, knockout people. MobX observables. I love Michael. He's a good guy. He called them observables because he started his stuff with RxJS, but those are really signals now. It's just they're named observables. It's got longevity. A lot of people use MobX. Solid.js signals. These are all similar types is what I'm getting at here. Vue refs, also signals. Angular signals, obviously signals. Svelte runes, sounds spooky, but those are signals, right? TC39 signals. So I'm involved in some discussions there about actually having these things standardized, because you can see nearly every framework, except for React, is using these, right? And I'm going to talk about why. So this is a possible waves hands. This is a possible setup for a signal, but I have this here because I want to illustrate to you what it is. You basically will subscribe, and it will notify you when it's changed, but not what the value is. And then you have a getter or a read function or something to get the value out when you want it or when you're ready to consume it, right? So you get notified a bunch of times, hey, this has changed, and then later, before you go to render your template or whatever, you say, okay, I'm ready for the value, I'm gonna get it now. So again, producer notifies consumer that something has changed, and then the consumer reads the value whenever it's ready. So what is this good for? You would, in a framework that uses something like this, you would have a couple signals that you can set, A and B, and then maybe a computed signal that does something costly, and obviously adding numbers isn't that costly, but in there that then depends on A and B to be added, and then you would have an effect that observes, in this case, C, and whenever C is changed, that effect would be scheduled and then fired at the framework's leisure whenever it needs to do that to process that side effect, whether it's updating the view or whatever it is people do in effects. Then people do horrible things with effects in React, so whatever you want to do. But yeah, and then you've got this idea of dependencies in there. Each computed properties depend on other signals, or computed signals depend on other signals. Effects depend on other signals, and what happens is that notification, hey, I've changed, goes from A to C, and then C says, oh, upstream's changed. Hey, I've changed, down to that effect, and that effect goes, oh, one of my dependencies has changed. I will schedule a read of my dependencies later on. So this, again, would be implemented by your framework or whatever to provide efficient updates. Now, signals are actually the dual of async iterable. And this is fun because I'm going to explain to you something I've been trying to explain to people in this TC39 group, and I don't think they've quite wrapped their head around it, or maybe they do and they just don't care and they want me to shut up, I don't know. Which is totally fine, I can understand that. All right, so this is my hand-wavy interface for async iterable. I'm making it hand-wavy because here we've got an iterator that just nexts out a promise of the value, right? I'm not worrying about the done part of this in here. And just so we look at this, if I have a method that returns an object with one method on it, right, that is just a function that returns a promise to the value, I can flatten that object out. I can just take the method off and return that directly because that's the only thing you're ever going to call it. So that's what I'll do. So now my iterator just gives me the next function itself, which you call to get a promise that pushes the value at you. Okay, cool. Now, I can replace that callback, or I replace that promise with a callback. It can do the same work, right? And the main reason I'm doing that is to make it easier for me to kind of invert control because promise is a little bit hard to deal with in that regard. So I've changed my promise to a function that takes a callback. Now the dual of a callback is just a function that returns the value. So I've switched that around. So right there, boom, switched it around. I'm working on a signal now. I've changed the name. And then I can invert the method. So instead of calling it iterator, I'm going to call it subscribe, just like I did with my observable before, and literally take the entire return value, and I'm going to pass it in instead. So again, inverting control. And then inside of that, I'm also going to invert control on that function and take the entire return value of that, which is the second part, that function that's pushing a value, or that function that gives you pull a value out of. And I will have a callback that basically pushes a getter at you. It pushes a function that you would pull the value out of at you. Everybody's looking at me like, what? All right. So hold on. So what we have now is you subscribe to this, and every single time the value changes, it says, here's a callback, and here's the getter for you to get the value. But the getter to get that value is not going to change between callbacks. It's always the same thing. Like, that's silly. This is a silly interface. So we can move that down here. And now we have our signal. The only thing that this is really missing at this point, just to go over this, I'm sorry. The producer will signal that something has changed under the hood, and then the consumer will have to get it with that getter value. And the only thing this is missing is a way to tell the producer to stop notifying me of changes. So we just add an unsubscribe on here, or you can pass it a cancellation token or whatever your API choice is there. So you need something for that. So this is just one possible shape for signal. But it is indeed the dual of async iterable, which already exists in the language. So I think it's a good add. I'm going to skip past this. This is actually a private repo. I'll have to delete this before I get to the next thing. I didn't realize it was private before I sent it in. Sorry about that. So we've got our four corners here. We've got pull, we've got push, we've got pull push, and push pull, right? And they're each good at a different thing. So pull, very, very simple. Everyone's used this all the time. It's good for getting any asynchronous value. More importantly, it's good for getting a value exactly when you want it. It's synchronous. You know when you pull, you're going to get that value right now, right? Push, this is really good for things like events and asynchronous value composition. So you have you want to take mouse movements after a mouse down until mouse up. This is what RxJS is good for. Push is very, very good for these things. Or it's good for when you have to wait for a producer to produce a value, right? So push is very, and it's good because it's simple. It's very, very simple contract. Unlike the ones at the bottom, which are obviously more advanced. There's multiple steps to the ones at the bottom. So pull then push, this is great for controlled delivery of those async values. So if you're worried about back pressure, or you're worried about, I don't know if I can process this fast enough per value, you want to do something where you pull some sort of push type and get that push, handle it, and then pull the next one. I don't care if it's async iterable or function promise or a function that returns observable or whatever that may be. There's all sorts of different shapes in there, but that's what that's good for, controlled delivery, managing back pressure. And then there's push, then pull. So this is really good for controlled reads of asynchronously updated values. If you've got a framework You don't want to render the view every single time someone like wildly updates values inside of something because they're getting some push stream that's updating values really quick. You only want to update when it's efficient. And so push then pull is really good for that. It can be lossy. There's some downsides to it, right? Like you could lose values in there, but what you really care about is what is the value right now after I was told it's been updated. The other thing to know about this is these are not the only shapes. You can build anything. You could have a reader that's pull, or you could even have a reader technically that's pulled and push. You could have tasks and actions that are push types. You could do an iterable of observable, or a function that returns observable, or you could do observable of iterables. People actually do this fairly often. It'd be like an observable of arrays of values, right? So there's, if you understand that these are the primitives you're working with, you can combine them, and they're in your code. I guarantee you're writing things this way, and you just haven't really thought about it. So there's just many, many permutations of these things. I've never gotten so far into push then pull then push or something weird like that. I don't really know that there's a lot of value to that, but if someone wants to write their doctoral thesis on that, I'd be happy to read it. Some are silly, right? An observable of, I don't know, an iterable of observables is probably kind of weird. I don't know why I would do that, but maybe. So the key types that you need to know when you're walking away and you're looking around, iterables. Anything that's an array, a set, strings are iterable. Many, many more types that exist are iterable. Anything you can consume in a for of is an iterable. Observables. So there's a W3C proposal right now that I'm working on that are trying to add observables to the browser to help manage how event targets give you events. There's obviously RxJS, which is what I work on. And there's so many more observable types. There's async iterables, which can be async generators, and some APIs now start to return these, and you can consume them with for await. And then there's signals, which are kind of coming into the public eye now, but have been around for a very long time, and are very useful for things like frameworks and rendering views. So the different roles or actors that I talked about earlier, again, are consumer and producer. These are really good to add to your vernacular when you're talking about code at work. This is the code that produces the value. This is the code that's consuming the value. Get it clear, work with your teams to understand and talk about things this way, and you will be able to communicate much more advanced things more efficiently. Pull is the consumer tells the producer to hand over the value right now when the consumer wants it. And it comes with the downside of if the producer can't give you the value right now, gotta luck. Push, the producer throws the value at Josh, throws a value at the consumer whenever the producer feels like it or whenever the producer's able to. Advantage being, producer has a chance to produce the value. Disadvantage being, it can be kind of hard for the consumer to make sure it has time to consume it. So, that's all I have on this talk. Hopefully you all go and you look at your code and you now see push and pull and consumers and producers, because I do promise you it exists everywhere. Thank you very much.